Hello guys, this video is for week 8, Algebra 2, day 1 only. The title is Modeling Population Change with E. Okay, so real quick, the assignment for this week is Monday through Friday you have 4 assignments and also 1 day of Carnegie. And we have a Zoom meeting on Tuesday and these are your due dates. Okay. Let's go back to our notes. Last week, let's review a little bit. Last week we talked about compound interest. We still were dealing with exponential functions, and compound interest is the one where you invest money and how much you get back with the interest. And if you remember, it was A equal P times 1 plus R over K to the KT. Okay. If you were using, this formula, usually in the question, they would tell you that it's compounded annually, semi-annually, monthly, or quarterly, or things like that. And then there's another one that we didn't cover last week, but then it's still compound interest. But this one is A equals P times e to the RT. This one right here is if compounded continuously. Okay, and there's no K involved because it's continuously. Okay, we didn't use this last week, but it's pretty important to know what that one is. And today we're going to mainly use this letter E. Okay, so E is actually a number, and this number, kind of like the pi is 3.14, right? E is around 2.7 with all these numbers in the back. And as you can tell, there's no pattern to this. So if there's no pattern to this, remember we call this an irrational number. Okay, so we're going to start with today's lesson, which is modeling or model population changes. The formula that we're going to be using to model population changes is really similar to this, we call this PERT. It's really similar to PERT, except the letter that we're using is different. So we have n of t and the function of n equal n sub 0 times e to the rt. Okay, and then we're going to explain what each of these letters represent. So let's start with this n sub 0. Okay, n sub 0 is the initial amount of population. Okay, and then r right here, r is the same as last time, which is the rate of growth in this case. Okay, next one we have t. Okay, t is time. Remember we already talked about e. E is a number, so we technically do not need to define it. And then the last one is n of t. So n of t is your result, which is population after t years. Okay, so I'm going to be using this formula and show you an example and then show you a question from the homework as well. Okay, so this question that we have right here is, it says the population of the city of Fredericksburg, Virginia was approximately 19,360 in 2000, and it has been continuously growing at a rate of 2.9% each year. Okay, let's write down the original formula first, which is n of t equal to n sub 0 times e to the rt. And then our main numbers, definitely this 19,000 number, 2.9%. And actually, year of 2000 is pretty important. Okay, and then since it says continuously, that's why we're using this formula. Okay, and then it says use the formula for population growth to write a function to model this growth. So we have to use whatever we're given so far to write the formula, which is this one right here is the initial, which is our n of t, or n sub 0. And then this one right here, we're going to be using that in a little bit. And this one right here, it's our rate. And when we write it, we have to change it to 0.029. Okay, so let's write the formula. We got n of t equals to 19,360 times e to the rate, which is 0.029. And our t in this case, we are going to write the, the year that gives us, like usually is t right here, right? But then this t really comes from the expected year minus year of 2000. Okay, so what that means is that, like, you know how we are starting at year of 2000? That's kind of considered as year 0. So if I want to, like, the next question, they want to find a function to model, to predict the population in 2020. That's 20-year gap right there. So we have to use 2020 minus 2000 to get our final answer. Okay, so right here, again, they want 19,360 times e to the 0.029 times 2020 minus 2000. Okay, so this would be e to the 0.029 times 20. So we're going to put this in the calculator. So let's put down 19,360 times e. So e is in the function right here. We're actually going to be using this one with the e to the x power. It's like the one under a to the b. Okay, and then I'm going to go back and type, put a parenthesis, 0.029 times 20. Okay, so it's 34,577.7. So 34,577.7. But since we're talking about population, we have to round it to the nearest whole number because we're talking about people right here. So this would be the answer. Okay. Letter C, it says, what value does your function model give the population of Fredericksburg in the year 1980? 1980 is 20 years back. So if I were going to write my formula, everything should still be the same except, what do you think I'm going to be putting up for T? You're actually taking 1980 minus year of 2000, right? So our answer for that, our result for a T is actually negative 20. Okay, so don't forget that negative because we are actually going to go back. We're going to subtract some numbers from our current population. And if you put it in a calculator, you should have gotten 10,840. Let me double check because I'm just going to put a negative right here. Yeah, 10,839.6, which you round it to 10,840. Okay, let's look at our homework. So our homework is page 2, and you got 6 questions. So I will do one of them for you. I will do number 1. Okay, so it says the population of Austin, Texas is growing at a rate of 2.9%. If the population in 2016 was about 913,917, what is the predicted population in year of 2025? Okay, so let's write the formula at the top. N of t equals to n sub 0 times e to the rt. And how many years is these two years apart? That's about 9 years. Actually, that's exactly 9 years, right? So we're going to be using 9 for t. And then our percentage, which is r, is going to be 0.029. And n sub 0 is the 900,000 one. Okay, substitute everything and then we'll be able to find our answer. So since we said our t is 9, I'm going to put 9 in here, equal to 900 something thousand times e to the 0.029 times 9. Okay, put it in your calculator. You should have gotten 1,186,472. This is estimated one. Okay, that's it. Finish the rest for your homework, and that's it for this video.